Okay, tables take a little bit longer to set up and go through the calculator. These go pretty quick. So using the graph of f to find the indicated limit and function value. Here we go. I'm going to take you through a couple and have you try some. Actually, I want to start with eighths. Okay, so this reads, here's the graph we're going to use. The limits of this generic function as x approaches 1. So here's an x value of 1. So just like from the table, what are we looking at? We're looking at values like 1.01 coming in from the right and like 0.99 coming in from the left, right? So as x gets closer and closer to 1, but not equal to 1, what are the y values converging on? So look across, they're converging on the same y value right here of -2. Again, so you can kind of use your fingers as a little bit of a help. As it approaches 1, but not equal to 1, what are the y values converging on? -2. Okay, like I said, just like from a table, 1.01, what would we say? I don't know, maybe -1.999? And what about 0.99? Okay, it's getting close to like -2.01. So the answer to that's -2. That's it. Okay. Now B, the point of B is it's not a limit. It's just going back to some basic function notation, making sure you understand the difference of when you're supposed to use the word approach for A, and B, this says find the y value at 2. Or, I'm sorry, at 1. All right. So this is when we use the word at, and this is when we use the word approach. What is the value at 1? If you look up and down here at 1, it is undefined. It is not there. There is no value. Some people also say does not exist. That's fine, but I'd rather you say undefined because that's how we typically answer that. Okay? Or maybe it will be defined. So number 6, if I look at f at 1 and just read the graph, at 1, where does the graph exist? It looks like now there is a coordinate associated with that. So I'd say -3. When x is 1, y is -3. Okay, so what's the limit as x approaches 1? Well, from the right and from the left, do we converge on the same number? Absolutely, because it was defined at that spot. So that's -3 as well. Sometimes they might have that same answer. Okay, so with that in mind, 6 and 8, that should be enough now to try 7 and 9. You pause and try 7 and 9. Give me about 1 minute. All right, so as x approaches 0, from the left and right, does it converge on the same number? It sure does. We'd say 2. What about at 0? Well, at 0, it's also 2. Sometimes it might not be. If it's an open circle, it might say undefined. Maybe it's even at a different spot altogether. We'll see that in number 10. Number 9. The function evaluated at -2. When there's an asymptote on graphs, we say that's undefined. Okay. So there is no value at -2. I don't see a coordinate. Okay. What about the limit? Well, coming in from the right, so if I'm coming in from the right, I'm looking at like -1.8 and -1.9. What's happening to these y values? They're increasing, right? So we got to look at two sides of this. So from the right, I'm going to write this in here. From the right, as x approaches -2, y equals, it's going up towards positive infinity. Okay, so from the right, as x approaches -2, y is heading up towards positive infinity. But we see something different from the lefts. So from the lefts, as x approaches -2, what do we see happening? Well, now I want to look at like -2.2, -2.1, -2.01. These y values are approaching negative infinity. So as x approaches -2, y equals negative infinity. Everybody see that? Coming in from the right and the left. My fingers are not converging on the same number. So we say it doesn't exist. Here it existed. Why? Because they're bumping into each other. Okay? Here they're not. So this is a scenario where we say does not exist. All right, number 10. So that's what we're going to look at. Now we're going to add one-sided limits. So I'll get maybe half of these going and let you finish. All right, so there we go. See that little notation? You got to look closely. As x approaches -1, this means from the left, right? From the left. Okay, so where's -1? Here it is, coming in from the left. I want to look at numbers like -2, -1.5, -1.1. What are the y values approaching? 3. I know they're not converging on the same number. A one-sided limit, you only need to use one finger. Okay, what is it approaching as it gets close to -1? It's approaching a y value of 3. Okay, so that's what we'd say. This one now says same c value or x value. Now it's coming in from the right, the other side. So as I get closer to -1, like a -0.9, where am I at? A -0.99. They're approaching a different number of 1. Okay, which leads me to this conclusion now. Are they approaching the same number? Because now it's not left or right-sided, it's a normal limit or two-sided limit. So since now my fingers are not approaching the same number, not bumping each other, does not exist. Like number 9. Okay. All right, so I think that's enough here. Now that I showed you one-sided limit, you got a couple one-sideds here, and then some normals, and then some ats. You finish those last 6. Again, if you know what you're looking for, should just take a minute or 2. Go ahead. All right, I'm going to go through these quick to wrap it up. So 1 from the left, coming in this way, it's approaching a y value of 2. From the right, what are the y values? When I get to like 1.01, looks like it's getting close to 2. Okay, don't worry, that's open circle right there. We'll take care of that later because at 1, which is what I is, there's nothing there. So we'd say undefined for that one. Okay, but these two, we're approaching the same number. So that leads us to saying that a normal limit or two-sided limit will be 2 as well. Okay. All right, as x approaches 5, sure looks like they're approaching the same y value from the left and right of 4. Okay, and at -1, here I have an open circle. Here they're trying to show a closed circle. If that was confusing you, it was like a filled-in dot. All right, didn't really make that obvious, so if that confused you, sorry. But yes, at -1, looks like it's defined as +1 for that one. It's kind of tricky. Okay, so that's the lesson today, tables and graphs. Let me show you how to kind of get number 1 going. They don't have the pre-made table set up, so what I'd recommend doing is, remember, here's what we're doing. Just x and y, or x and f of x. Your number, the c value kind of goes in the middle. So you should put 3 here, and then take a look at a couple of small values to the right, take a look at a couple of small values to the left. That's how I'd set up all of these. Okay, so for number 3, you're going to put 4 in the middle when you set that up. Go to your table, just go by hundredths is usually enough, copy down the y values, and then you'll be able to get the answer. Okay? For 4, you just got to make sure you're in radians mode for this one. So heads up on that. Make sure you're in radians mode before you throw that in your y equals. Radians mode for 4. Okay, so your assignment's going to be 1 through 14, because then you got some more tables, and then these graphs go pretty quick. Go and do 1 through 14. Okay?